So range chart or R chart. This is used to control. This is used to control dispersion or variability of product under process. To find variability under process, any variations are there for the described standards and the manufacturing product. Is there any variability are there? To detect that one, whether the process is under control or out of control, to find, we draw a range chart. How to draw this range chart? So here, to draw range chart, you need to follow these steps. First, range R of given samples. Find range R of given samples. Find range R of given samples. Next, calculate mean range of samples. That is, we represent that one like R bar. Next, calculate standard error of R bar, standard error of range, that one we need to calculate, sigma R bar. Next, the control limits are given by control limits for R chart are UCLX. CL is control line is R bar. UCLX, upper control limit, you will get R bar plus 3 sigma R. LCL, lower control limit, R bar minus 3 sigma R. Whenever standards are not given, we take control limit as R bar only. Upper control limit as table value, that is D4 R bar. This is table value. You will get from table D3 R bar. When sigma we can find, we will use these 3 sigma limits. We call these are 3 sigma limits. Whenever we don't have sigma value, we take these. So like this, we can draw the control line, upper control line and lower control line. Here R bar values you will take, here sample numbers. This is CL, UCL, LCL. If you draw the range chart, if it is between UCL and LCL, process is under control. If the graph crosses UCL and LCL, we say that process is out of control. Like this, one can easily draw the range chart. When range values are given or when samples are given, we can find range. Range means highest value minus smallest value. If a size of sample is 5, if you have 5 values, in that find out what is the highest and what is the smallest value. Subtract them, you will get range. Finding range R bar is nothing. Range R bar you will get sigma R by n. Okay. Any doubts you may ask. The following values gives range R for samples for size 6 each. Calculate the value for center line and the control limits. Center line control limits. Range chart. For range chart, control charts, draw the control charts and comment the state of control. So we need to draw the range chart. And we need to comment state of control means whether the process is under control or out of control, we need to decide. For that, for range chart, the control line is R bar, we know. So that is, we need to find R bar. R bar means sigma R by L. You need to add all range values. If you add all the range values, you will get 58. 5 plus 6 plus 5 plus 7 plus 7 plus 4 plus 8 plus 6 plus 4 plus 6 by 10. You will get 5.8. Coming to the control line is R bar only. That is center line. Center line is 5.8. Upper control line for R bar is D4 R bar. This is from table. There is a table, control charts table in your textbook. You can find that one. So from that you need to calculate D4 value. See the table value, 2.004 into 5.8 you need to calculate. It is approximately 11.623. You will get. Like that, calculate LCL R bar. That means lower control line or lower control limit. D3 R bar. This is also you will get from the table. For n equal to 6, you will get. For n equal to 6. For n equal to 6 from table. This will be 0. 0 into 5.80. So lower control line we need to write at 0. That is axis only, horizontal line only. Upper control line at 11.6 and control line at 5.8. So now we are going to draw the range chart, R chart. So here vertical line and horizontal line. Here you need to give the sample numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Coming to here, the range is also up to 10 only, but control lines you need to draw at 11.6, right? That's why take 2, 4, 6, 8, 10, 12, 14, 16, like that. So control line is at 5.8. 5.8 means here you will get. The lower control line is this line only. This is central line. LCLX, LCL R bar. That is that one only. That line only because 0 line. Next, upper control line at 11.6. 11.6 means approximately here. So this is LCL. Now we need to draw the range values. By plotting range values in the graph, you need to draw the graph. For 1, what is range value? For 1, the range value is 5. For 1, range value is 5. 5 means, so here control line is 5.8. 5 means you will get here. For 2, the value is 6. 6 means here above the control line, central line. 3 is 5. 3 is 5 here. For 4, you will have 7. 7 above the control line only. 5 again 7. for 6-4, for 6-4, for 7-8, for 8-6, for 8-6, for 9-4, for 10-6. Now join this graph, you will get like this. So if you observe, the complete graph is in between UCL and NCL. This is UCL, upper control line. The complete graph is in between upper control limit and lower control limit. So in between these two, then what we can say, the process is under control. From the graph, we can easily comment about the status of process. The process is under control. So comment on state of control. The state of control is under control, not out of control, because the complete graph is in between UCLX and NC, UCLR and NCLR, in between upper control and lower control. When you have graph like this, process is under control. When graph crosses this line and this line, we call that is out of control. But here the process is under control based on R chart. Any doubts you may ask? To draw any control chart, these three are important. These three are important. If you can find these three, one can easily draw any chart. Okay.